Greetings and welcome to Flanigan's EcoLogic. I am your host, Ted Flanigan, and this episode of EcoLogic covers EcoNet News, Volume 25, Issue Number 7, July 2023. Flanigan's Net Positive, China's Renewable Energy Revolution in Perspective. This is amazing news. Sure, there's more to be done, but let's relish in the goods. China may reach its aggressive renewable energy target 5 years early. It's a country that the Washington Post noted is light years ahead of the U.S. in building clean power. In 2022, China finished the Bahetan hydroelectric power project, the country's second largest hydropower station. China is not only powering an ever-increasing slice of its own economy with renewables, largely solar and wind, but it is providing products like solar panels all over the world. As has been reported in EcoNet, China is the world's factory. Chinese-made PV modules, wind turbines, gearboxes, and other key components made up for 70% of the global market share last year. Global Energy Monitor is a San Francisco-based nonprofit NGO which catalogs fossil fuel and renewable energy projects worldwide. Its global solar and wind power trackers identify prospective projects that have been announced or are in the pre-construction or construction phases. According to its data released in June, China is on course to hit its 2030 target of 1,200 gigawatts of renewable energy capacity 5 years early. That's impressive. Time to increase the goal, to raise the bar. Absolutely. Martin Wheel at the Global Energy Monitor makes clear that baseload coal is still holding sway as the dominant power source. Others take it a step further, suggesting that the boom in renewables is sadly going hand in hand with the boom in coal-fired power plants. Every one of the coal-fired power plants that made up 40 gigawatts of capacity that was given the go-ahead last year was in China. The world consumption of coal would have peaked in 2018 if not for China's continued development of coal plants. This has added 862 million tons of annual coal production and consumption. A massive project in Mongolia features 16 gigawatts of solar, 4 gigawatts of wind, and 4 gigawatts of coal. Let's get back and put China's renewables in perspective. According to the Bureau of National Statistics, and when considering all power sources, in 2021, China had 2,380 gigawatts of installed electrical capacity. By the end of 2022, the capacity had grown to 2,564 gigawatts. That compares to the 1,160 gigawatts in the United States. China is forecasted to have 3,000 gigawatts of demand by 2025. Currently, China has 757 gigawatts of operating wind and solar, already 30% of the nameplate capacity. Watch this space. In addition to the existing 757 gigawatts, there is 750 gigawatts of prospective wind and solar, the majority of which is expected to come online by 2025. That is made up of 379 gigawatts of utility-scale solar and 371 gigawatts of wind capacity. If all prospective projects are built and commissioned as planned, it will equate to a doubling of all China's utility-scaled solar and wind power capacity. China is spending $250 billion a year on renewables, as much as the rest of the world combined. It is installing nearly half of the world's new renewable energy capacity. Already the numbers are impressive. China's operating utility-scaled solar capacity is 228 gigawatts, more than the rest of the world combined. The world's leading solar panel manufacturer, the Chinese company Jinko, is producing 30 gigawatts of panels a year. That's not a typo, nor is it off by an order. China's wind capacity has doubled since 2017 and now stands at 310 gigawatts. Of this, Offshore wind is about 10%, or 31.4 gigawatts. That's more than all the offshore wind capacity in Europe, where there is 22.07 gigawatts of capacity made up of 5,047 turbines in 12 countries. So hats off to China for being a leader in renewables. Its next step is to seize the opportunity now to fully green its power sector. Quote of the month. This new data provides unrivaled granularity about China's jaw-dropping surge in solar and wind capacity. As we closely monitor the implementation of prospective projects, this detailed information becomes indispensable in navigating the country's energy landscape. Dorothy May, Project Manager, Global Energy Monitor. U.S. EV charging networks. The U.S. Department of Energy's Alternative Fuels Data Center tracks access to alternative fuels, such as electricity. It finds that there are around 50,000 public EV charging stations in the country. That compares with around 150,000 conventional gas stations. Like gas stations with multiple pumps, each EV charging station has multiple electric vehicle supply equipment, or EVSE ports. The 50 stations across America have around 130,000 EVSE ports. So which is the biggest charging network? ChargePoint is the answer. It has 27,000 stations and 50,000 charge ports. Number 2, that's Tesla with 6,000 stations and around 28,000 charge ports. Tesla is the leader in fast charging stations, the level 3 variety. Most ChargePoint stations are level 2. The speed of charging is a big differentiator. While home or hotel use allows the use of level 2 overnight charging or topping off, along highways charging speed is essential. Of the 50,000 charging stations, 44,000 are level 2 stations, with over 100,000 charge ports. Recent data shows 6,600 DC fast charge stations with around 28,000 charging points. Tesla is the only auto brand that owns and operates its own proprietary charging network. Its superchargers max out at 250 kW, equating to 200 miles of range in 15 minutes. Tesla has 1,600 supercharger stations in the U.S., with 17,000 fast charging ports. Next in line is Electrify America, with 800 stations and 3,600 fast charging ports. EVgo has 2,200 fast charging ports. ChargePoint has 1,800. Another key parameter is price. How much does the power cost to fill your EV? The other day in San Diego, the Tesla supercharger price was 32 cents per kilowatt hour on a Sunday afternoon. Users access ChargePoint chargers using the ChargePoint app. Some cities have offered charging for free, some to the public, some limited to employees. Other chargers take credit cards. Others can only be accessed via membership with a credit card on file. Electrify America is owned by Volkswagen Group of America. It has a partnership with Ford. Every Mach-E buyer gets 250 kilowatt hours of fast charging on its network. VW was required to build out that network as part of the settlement with the government related to its diesel emissions scandal. Its chargers can charge at up to 350 kW. Electrify has a comprehensive network. It boasts that its users can take their EVs coast to coast using its charging network, allowing for a non-Tesla EV road trip. Greenlots is a charging network that is based in Los Angeles. It is owned by Shell and plans to convert Shell gas stations to EV charging stations. Greenlots is being rebranded as Shell Recharge. Francis Energy is a supercharger network from Oklahoma. There is no question that an underpinning of the transition to EVs is fast charging, allowing for quick and easy refueling, especially on road trips. Fast charging is the only practical level of charging for long-distance travel, but fast chargers are a fraction, less than 20%, of the total number of EV chargers nationwide, and 60% of them are in the Tesla network. The federal government is now squarely behind charging. It is investing $5 billion to launch a national EV charging network. Last September, the DOT approved plans from all 50 states to build a nationwide network of EV chargers. NEVI will create a generation of good-paying jobs building a nationwide network of EV chargers, noted Secretary of Transportation Buttigieg. These are big steps towards the goal of 500,000 public EV chargers by 2030. Clean energy job growth. The U.S. Department of Energy has released its 2023 U.S. Energy and Employment Report. Overall, almost 300,000 workers were added to the energy workforce in 2022, a 3.8% growth rate over the prior year. The data shows strong growth in clean energy jobs, spurred by investments from the Infrastructure Investment and Jobs Act and the Inflation Reduction Act. In 2022, there was growth in almost every state. Overall, clean energy jobs increased by 3.9%, adding 114,000 nationally, representing over 40% of total energy jobs. Solar and wind accounted for more than 84% of the net new electric power generation jobs, adding 21,000 jobs, a 3.6% growth rate. States with the greatest clean energy job growth were California, which added 13,000 jobs, 3.2%. West Virginia, which added 7,000 jobs, 19% growth rate. And Texas, which added 5,100 jobs, 3.5%. Jobs related to EVs were up 21%, adding 38,000 jobs. The U.S. EER report began in 2016 to track employment within key energy sectors: electricity production and generation, transmission, distribution and storage, energy efficiency, and electric vehicles and component parts. In related news, McKinsey's Graphics of the Week reports that wind, solar, and storage growth has almost tripled with the passage of the Inflation Reduction Act. Before the IRA, the growth rate was 6% per year. After the IRA, it was 16%. The McKinsey proclamation is in line with the Lawrence Berkeley National Laboratory portrayal of the national utility interconnection queue. Volkswagen Group France commissions 20 megawatts of solar. The Volkswagen Group is about to commission another major solar installation, this time at its facility in the Villers-Cotterêts, France, in the northern Hauts-de-France region. The 20-megawatt solar installation has been constructed and financed by Engie. Two 10-megawatt arrays cover a 15-hectare parking lot. A VW representative noted that the solar-covered parking area is fully in line with the German company's Go to Zero strategy to reduce its carbon footprint. Engie Green, the renewable energy unit of the French energy group Engie, developed the $21.8 million solar system. Engie will own and maintain the facility for 32 years. The project was supported by the French Ministry of Ecological Transition through a tender process in 2020 and 2021. The project also got support from crowdfunding from local communities. VW's goal is to be 100% renewably powered by 2023. In 2020, the VW Group increased its use of renewables from 80% to 95%, when 10 of its big factories became 100% powered with renewables. 8 sites are in the EU, 2 sites are outside the EU. The largest sites were the Audi plants in Hungary and Germany and the VW plant in Portugal. All told, the sites are located in 7 countries. Note that these values are based on offsetting the external supply, the power that VW buys from the grid. When factoring in process heat and cogeneration on site, renewably sourced electricity accounts for 46% of the company's energy needs, up from 5% in 2019. VW also has its own power plants that base its carbon footprint. Its coal-fired units at its Wolfsburg plant will be converted to natural gas, reducing emissions there by 60%. the most efficient cars. The highest U.S. Environmental Protection Agency rated cars in the model year 2023 are now public. For gasoline vehicles, the highest fuel economy with 60 miles per gallon, or MPG. For EVs, the Hyundai Ioniq 6 and the Lucid Air achieved 140 mile per gallon equivalent. Not far behind are the Chevy Bolt at 120, the BMW i4 at 113 mpg, and the Porsche Taycan at 83. EPA uses 37.7 kilowatt hours per gallon of gasoline to compute the comparative MPG rating for EVs. This is based on 115,000 BTUs per gallon of gasoline and an industry standard efficiency of a conventional thermal power plant of 3,412 BTUs per kilowatt hour. As less conventional power plants exist, EPA may change its industry standard measure. EV MPG may well increase as a lesser BTU value is used in the future per kilowatt hour. For model year 2011, 12 years ago, the maximum fuel economy of gasoline-powered cars has increased by 19%, while EV efficiency has grown 37%. All of these are based on EPA's combined city highway fuel economy rating. At the other end of the spectrum, EPA's survey revealed 17 vehicles sold in the United States that get less than 17 miles per gallon. These come from brands including Bugatti, Bentley, Mercedes, Rolls-Royce, Lamborghini, Cadillac, and Dodge. Wind updates. 16 megawatt wind turbines. Just months ago, EcoNet reported on record-sized wind turbines. Now the first 16 megawatt turbine has been installed and is in offshore operation in China. These massive turbines are being built, owned, and operated by China Three Gorges and Goldwind, part of CTG's Jiangsu Iloha offshore wind farm. Goldwind's GWH-252 has 404-foot long blades, a rotor diameter of 830 feet, and a swept area of 538,195 square feet. Each spin of the turbine results in 34.2 kilowatt hours of power. Vertical axis turbines. Swedish wind turbine maker Sea-Twirl reports that it has received its first order for its novel vertical axis turbines. They will be deployed in the North Sea. The agreement signed with early-phase offshore wind developer Kontiki Winds is for Sea-Twirl's S1 model. The S1 is a 30 kW floating turbine designed to withstand the demanding conditions in the North Sea. Sea-Twirl is configured 43 feet above sea level and 59 feet below. S1s can be placed in dense pack for increased output. Offshore wind turbines are generally limited to be tethered and anchored in maximum depths of 200 feet. Sea-Twirl's turbines can be anchored in much deeper waters. Global installed wind capacity. There is now 1 terawatt, or 1,000 gigawatts, or 1 million megawatts, or 1 billion kilowatts of wind capacity globally. According to the Global Wind Energy Council, GWEC, it took 40 years to get here. That time frame began when Danish engineers began to experiment with the designs that now serve as the foundation of the current wind industry. GWEC chairman Jonathan Cole warns that while this is an immense achievement, it still represents only a small portion of what must be built in the coming years in order to decarbonize our planet. While it took 40 years to achieve the first terawatt, GWEC forecasts another 2 terawatts in the next 7 years. Solar O&M for aging systems. EcoMotion is pleased to welcome Simon Kaplan as an intern. He is finishing up his final year at Columbia University, where he is a Klug Scholar and a Sustainable Development major. For EcoMotion, Simon has done research on operations and maintenance, O&M, providers for aging solar systems. Where can solar system owners like school districts turn for help? The research was focused on commercial customers, with Southern California the primary target for listing of providers. That said, Several listed in the spreadsheet of providers are national. EcoMotion is in the business of providing solar consulting services. Recently, we've been involved in performance monitoring and repair of aging systems. Visit ecomotion.us to download Simon's research paper and also the spreadsheet of solar O&M providers. That's it. Thanks for listening to Flanigan's EcoLogic. We'll see you next time.